Respected members, myself is Dr. Sarika Saxena, working as a professor in Amity University Uttar Pradesh, Noida, India. I am going to present the work on the structural studies of the peptide, first time identified from the 2KRR domain of the nucleolin protein with CMYC G4 structure. Here I am going to present the structural changes in CMYC G4 structure upon NU peptide binding using CD spectroscopy. CD spectroscopy was performed in dilute cationic conditions of sodium and potassium with and without NU peptide. The structure of each DNA strand was recorded in the presence of 30 millimolar sodium caprolate buffer pH 7.4 and 100 millimolar sodium and potassium in the presence and absence of NU peptide. CD spectra in 100 millimolar sodium was characterized by a positive peak at 265 nanometer and a negative peak at 237 nanometer, which is typically observed for parallel G quadruplex. The structure was then titrated with increasing concentration of NU peptide to determine the conformational changes in G4 structure upon peptide binding. We observed a change in a CD intensity at 237 nanometer, but a slight change in the CD intensity at 265 nanometer was observed upon titration with two isotachoric points at 229 nanometer and 254 nanometer. However, these changes in the intensity were not very significant, but the presence of isotachoric points indicated that the peptide was binding to the G4 structure, but did not cause a significant change in the conformation of the G4 structure in the presence of sodium. In contrast, the CMYC promoter G4 in the presence of potassium ion exhibited a strong positive peak at 268 nanometer and a negative peak at 239 nanometer, indicating the same characteristics of parallel G4 structures. On titrating this G4 structure formed in the presence of potassium ion with an increasing concentration of NU peptide, the positive peak at 268 nanometer shifted to 271 nanometer with a decrease in the CD intensity at this wavelength and a complete disappearance of the negative peak at 239 nanometer. We also observed an isotachoric point at 252 nanometer, indicating that the NU peptide bonded strongly to the potassium ion, formed CMYC G4 in comparison to sodium and caused a conformational change, possibly due to the binding of the peptide in the loop region of CMYC G4 discussed further in the UV thermal melting data. As significant changes were observed in the CMYC G4 with NU peptide in the presence of potassium, hence CD melting studies of CMYC promoter G4 structure in the presence of potassium ion were performed with and without nucleolin peptide. These different DNA peptide ratios 1:0, 1:20 and 1:50 were prepared and recorded temperature dependent CT spectra at 5 degrees Celsius intervals starting from 20 degree to 95 degrees Celsius were recorded. The change in the CD intensity against the temperature was plotted and we did not observe any significant change in the TM value, but the percentage of hyperchromicity increased upon increasing the peptide concentration. These CD melting results confirmed the binding of the NU peptide to the CMYC promoter G4 structure in the loop region, and its stabilization is possibly due to the increase in stacking interactions. Next, we explored the thermal stability of the CMYC G4 structure with and without the NU peptide. In the figure, we have shown the normalized UV thermal melting curves of 4 micromole CMYC promoter G4 in a buffer containing 100 millimolar sodium and potassium in the presence and absence of NU peptide at 295 nanometer. The different DNA to peptide ratios were used for recording the changes in the CMYC G4 structure upon peptide binding at 1:0, 1:2, 1:5, 1:20 and 1:50 respectively. The melting temperature was evaluated by a curve fitting procedure described previously, and the TM values varied from 51.8 to 55.5 for sodium and from 87 to 88.5 for potassium. Next, we explored the thermal stability of the CMYC G4 structure with and without the NU peptide. Figure shows